So for the last part of exercise 5.3.8, they're asking us to integrate x squared times the square root of x minus 1 dx using u substitution. So the first step is choosing our u, which is going to be a function that is inside another function. In this case, it's x minus 1. So our u value is going to be x minus 1. And our du is going to be dx. Because the derivative of x is 1 and the derivative of minus 1 is 0. So it will be 1 dx or only dx. Now, notice that with these two, we cannot cancel the x squared that is here. So we need to find what is the u value equivalent to x squared. So we know that u plus 1 is equal to x. So that means that u plus 1 squared is equal to x. So now that we have all the terms, all the x in terms of u, we can go ahead and substitute all the x's for u's of this integral. So there's gonna be the integral of u plus 1 x squared times the square root of u du. Now, in order to make it easier for us to solve this integral, we're gonna expand this u squared. It is u plus 1 squared. So it's gonna be equal to the integral of u plus 1 times u plus 1 times the square root of u du. So now we can multiply all together. So u times u is u squared plus 2u plus 1 times u, the square root of u du. So that's gonna be equal to the integral of u to the 5/2 plus 2u to the 3/2 plus u to the 1/2 du. So we can go ahead and solve this integral, which is going to be equal to u to the 7/2 divided by the 7/2 plus 2u to the 5/2 plus u to the 3/2 du. So now, which is also equal to 2 to the 7 u to the 7/2 plus 4 to the 5th u 5/2 plus 2/3 u to the 3/2 plus c. If we want to this integral, we can take out this u. So it's gonna be equal to u 3/2 times 2 to the 7 u squared plus 4 to the 5th u plus 2/3 plus c. Now we can go ahead and substitute the values of u, which is going to be equal to x minus 1 3/2 times 2 to the 7 x minus 1 squared plus 4 to the 5th x minus 1 plus 2/3 plus c. And this is gonna be our last result. So now they're asking us to integrate x times the square root of x squared minus 1 dx. So as mentioned before, for our u value is gonna be the function which is inside another function. In this case, it's the x squared minus 1 because it's inside the square root. So that's gonna be our u. So u is gonna be equal to x squared minus 1. And our du is gonna equal to 2x. Notice that we cannot, with this value of du, we cannot cancel the x that is inside. So we need to find another way, which is gonna be like, if du is equal to 2x, we know that 1/2 du is gonna equal to x. So if we rewrite this integral in terms of u, that's gonna look like this. 1/2 square root of u du. We don't put any more the x because it canceled with the value of the u. So we're gonna solve this integral, which is gonna be equal to 1/2 the square root of u to the 1/2 power du, which is gonna equal to 1/2 times u to the 3/2 divided by the 3/2 du, which is going to equal to 1/2 times 2/3 u to the 3/2. Sorry, here's not the u, because we already solved the integral, and when we solve the integral, du cancels. Instead it's plus c. So now this is gonna simplify. 1/3 u to the 3/2 plus c, which in terms of x is gonna be 1/3 to the x squared plus minus 1 to the 3/2 plus c. And that is gonna be our final answer. So for the last part, they're asking us to compare how the results of the three integrals that we made change with only changing one variant. So here we noted that the only difference from this integral and this integral is the x squared that is outside the function. We can notice that even only with that change, we had two completely different answers that doesn't look similar because in this case our value of x is only u plus 1, and here our value of x squared is u plus 1 squared. So notice that change. And now in this case of this one, now we have the x squared inside the function. This changes completely our value of u and also of du. Du in this case is going to be 2x. And we know that in order to cancel the x that is outside, we need to convert. We know that the half of du is equal to x. So, because if du is equal to 2x, 1/2 of du is equal to x. So yeah, you can notice how all three answers are very different.